Hello, is it me you're looking for? When you walk into class really, really high in front of everyone. As he's like creeping in, and like everyone's still watching him though.
He's over here like, and you just close your eyes.
What the hell? I'm hunting wabbit. Okay, anyway. Okay, yeah. Hey. Alright, so again, I said that we are skipping a whole bunch of stuff because it's not part of the BC curriculum. But that still means that we've got a lot more stuff to do. Yeah. Okay, so what am I going to tell you? Thank you. Alright, so, and give my ball back. So, for here, partial fraction, integration, and logistic model. So, everyone loves those games where you actually kill the whole world, right?
Yes.
You know, where you actually like start some virus or parasite. Yeah, like play games. Okay, we're going to do the math on that. We have the math for that now. So, everyone knows you have to start in either Greenland or Madagascar, right?
Yes, Greenland.
Greenland or Madagascar?
I start in France because they start the cure the fastest.
Or in India. Because they have the worst medicine.
Well, that's true. That's true.
Okay, so either way. All right, so integration. Integrating an improper rational. Improper. What is an improper fraction? Nope. Wow, I'm like trying to sneak all the way back down to like first grade type stuff.
The fraction that doesn't have manners.
The fraction
Is it like one
is
is
Yeah.
No, that's a mixed fraction.
Is it? Would it then be 7/4?
7/4. Why is 7/4 improper?
The top is larger than the bottom.
Yeah, that's why.
Oh.
What? Okay.
Improper means top number's bigger than the bottom. So this one's going to be talking about degrees. So top bigger than bottom. Yes?
Yeah.
Okay, so what we're going to do with this is, starting on this one, I'm going to start by doing some long division here. Okay? So we're divided by the bottom, but since the bottom, top is bigger than the bottom, so watch this. So I'm going to start by going x minus 1, so here's my long division, and it's going to be x squared plus 0x plus 0. I'm accounting for all things. Okay. But I don't need that. Okay, so now whenever I'm doing this, I'm always trying to match the leading coefficient. The leading coefficient, I'm trying to cancel out the first one, right? So to cancel out my first one, I have to multiply by x, right? Yeah. And this has two terms. It's a binomial, so therefore I have to go over 2 here. So it's going to be, I'm going to multiply this by x, right? X. So it's going to be an x here. So when I multiply that, it's going to be x squared minus x, right? Yeah. And whenever I do this, I have to subtract that. Sorry, you guys.
You're dying on video. We'll still upload it. Don't worry.
I know. Get YouTube a virus. All right, I'm subtracting this right here. So now that I have that, let's go ahead, because that's going to get rid of my leading coefficient. My first term is always going to go away here. So that's going to give me 0 because it's x squared minus x squared, right? And now this is going to turn into a plus x, right? Okay, so it's plus x, so it's a positive x. So 0 plus 1 is just there. Bring this down. So it's plus 0, right? And so from here, I have to put what? So over here, to match this, what do? I need to match this. Are they the same sign? They are the same sign, so therefore it needs to be a positive, right? And if there was a different sign, I would put a negative. But since it's x and x, it's just going to be a plus 1. So 1 times this is going to give me x minus 1. And I'm subtracting that. So that goes away, and this is going to be plus 1, right?
Okay.
Because I have to distribute the negative.
Yeah.
Yeah. I'm distributing the negative because I have to subtract that whole thing. So now what is that? What happens with that 1? Go back to, I don't know, 3rd grade? When did you guys do? R1. Very good. That is exactly right. You have a remainder 1, right? Okay, my remainder's 1, but how am I going to rewrite my remainder though?
1 over x minus 1.
Very good. So it's plus, right? 1 over x minus 1. So I'm going to change up my integration now. So my integration, I'm going to rewrite it. It's now going to be the integration of x plus 1 plus 1 over x minus 1, and that's going to be my dx. Is everyone okay?
Yeah.
I didn't lose anyone, right?
Me, but I don't know how to do divisions and stuff.
Divisions?
We didn't really learn long division, at least.
I know, that's why I'm going
Yeah.
over this. I'm not expecting you to know it. Be like, oh yeah, do this, you know. But okay, are you okay
I'm starting to
with?
understand it though.
Are you okay with what I did here, or no?
No, because I need to review it. I'll do it.
Okay, so but are you understanding the concept of what I did? Because this is the division, right? So if I put some numbers in here and say that's 25 over 3, right? My long division would look like this. It would look like 3 on the outside and then 25, right? Yes? And so how many times does 3 go into 2? 0, right? It goes in 0. And now how many times does 3 go into 25? Okay, that's going to be what? 7, 8? 8. That would be 24, right? So 8 times 3 is 24. But what am I doing with that? I'm subtracting it, right? And so that's going to leave me with 1. And that would be my 1, okay? And this would be a remainder, so that's 1 over 3. So that's 8 and 1/3.
Okay.
So it's the same thing with numbers, but we're doing it with polynomials now. Yes?
So x minus 1 goes into x squared 0 times, or it goes into x squared plus 0x x times? And you
Yes.
multiply x by that and you get that.
Yes.
And then x minus 1 goes into x plus 0 or 1 time.
1 time, yep.
Why you
Yeah, and so if you notice, I'm not going any further than this right here because I have to have 2 terms all the time.
Yeah.
Since I have a binomial,
That's
I
nice.
can't do it again.
Yeah, yes, I know that.
I need to have 2 terms, and that's why it stopped right here, and the rest was remainder. Okay? All right, so now let me clear up what I did here. We're gonna do this again. I'll give you guys another problem right here to help concrete your understanding of this. All right, so now let's take the integration of this now. So if I integrate this, it's going to give me x squared, right? Over 2 plus x plus, what's the integration of 1 over x? ln, right? So this is going to be x minus 1, so it's going to be an integration of ln of x minus 1, right? And then plus c. Why am I putting the absolute value there?
Yeah, it can't be.
Can't be negative. So it has to be the absolute value. All right, are we okay now? No? Maybe? All right, so that's the answer for that one. Okay, so I'm going to insert a new page and I'm going to give you another problem just so you guys could actually try to practice this one. Thought I had another problem here. have one, but. So x squared plus 4 over x plus 2. Okay, and that's going to be a dx. All right, so this is your practice. So practice this. I'm going to let you guys work this. I'm even going to pause the video for those other people. Okay, for all those people that were, working with the, at-home version of this game, x minus 2, it's going to be x squared plus 0x plus 4. Okay, because I have to account for every degree, right? Okay, so since I'm counting for every degree, so I'm trying to max this first one. So two terms over, so it's going to be an x, right? And it's going to become x squared minus 2x, parentheses around that, and I'm subtracting. So that's going to give me that goes away, and so it's a plus 2x comes down, bring down my plus 4, and then I'm trying to match this one again, so it's going to be a plus 2. This is going to make that one plus 2, and then that's going to give me 2x minus 4, right? So 2x minus 4, and now parentheses around that, subtract. So that's going to give me what? 8. So my remainder is 8. So it's going to be plus 8 over x minus 2. So my integration now is going to be from x plus 2 plus 8 over x minus 2 dx. And so from here it's going to be x squared over 2 plus 2x plus 8 ln absolute value of x minus 2 plus c. Are we okay?
Yes.
Okay, good. All right, so let's go back to right here. All right, integrating rational function whose denominator contains only a distinct linear factors. Linear, what does linear mean? What's the degree? 1. The degree has to be 1. Degree has to be 1 for it to be linear, right? Okay, good. That's the point. So now this is actually where we're getting into actual partial fractions. So find this. We have p of x over q of x dx. Integrate both sides of this. We have to break it up into 2 separate parts. So I need it to be 2 separate parts. Okay, so now denominator contains only distinct linear factors. Okay, linear factors now. What does linear mean? Gotta have degree of 1, right?
Yes.
So we're gonna break this up now. So what we're gonna do, let's factor the denominator. Factor the denominator. Factor it. So we're gonna get what? So it's going to break up into integration of x over x what? Minus 2 and x minus 3 dx, right? Okay, so whenever we get problems like this, we have to break it up. Now we have linears, and now we're going to have to go through and do the full thing. So this is going to break up into 2 separate parts. So it's going to turn into x over x minus 2, x minus 3 is equal to a over x minus 2 and plus b over x minus 3. Now, what we're trying to do is we're trying to go through and solve it using, this is going to come up like a system of equations. This is straight, pure algebra at its finest. So, we're going to multiply everything by the common denominator, right? What is my common denominator? Both sides of the equation. What is the common denominator?
X squared.
So it's going to be x minus 2 and x minus 3, right? So if I multiply both sides of this equation by that common denominator, what's going to happen to the left? Say it goes away. That goes away, right? That's going to go away. So that's going to help me out. But then over here, this is an x minus 2. What is this one right here missing? It's missing an x minus 3, right? So I'm going to rewrite this by multiplying out the common denominator. So it's going to be x equals. So this was missing an x minus 3. So now it's going to be a quantity x minus 3 plus b quantity. This one is missing an x minus 2, isn't it?
Yeah.
Okay. X minus 2. Now, given that much information, I can go through and do a bit of distribution here. Okay, a bit of distribution. So now, on my x side, it's going to be x equals ax, right? Minus 3a plus bx minus 2b, right? Yeah. Now, this is going to be the creative part. We go by degrees here. So we're going to put the x's together first and factor it out. So I know that by degrees, it's going to be x, and then it's going to be these two together, which would be a plus b, right? And then over here, for my other degrees, okay, other, it would be minus, right? Minus 3a, and then it's going to be minus 2b, and all this is equal to my x. Now, because of the degrees, the degree side are going to be equal. What is the number in front of my x? 1, right? So I know that since there is a 1 here, right? There's a 1 here. 1 is going to have to equal to this part right here. Because these go together. The degree parts together. In a polynomial, all the a squareds are supposed to be equal, or I'm sorry, the x squared is supposed to equal all the rest of the x squareds, right? So if I move everything to the left side, it's all going to come out together. It's all going to be equal on both sides because of this has to come out like that. In algebra, both sides, left side and right side, are always the same. Okay? They're always going to be the same. They are balanced. There's an equal sign in between them. Therefore, the left side must be equal to the right side. So, by degrees, this right here, so 1 is equal to a plus b. Okay? Now, the other part, what was my constant right there? Do I have a constant right there? It's just x. Okay? If it's just x, what is the constant? What is the number that doesn't have a variable? Say it.
0.
0. Thank you. There is no constant, right?
Yeah.
So I could say that 0, because there was no constant over here on the left, 0 is equal to my
3a.
negative 3a minus 2b. Go ahead, speak, ask questions now. Because like I said, this is just pure algebra. This is where a lot of people, have forgot because, they got hit in the head with the soccer ball too much. Okay, if you have questions, you got to ask now. Caged animals. All right. So, this is going to be a system of equations. So I'm gonna bring this over to a new page, and I need you to. So it's gonna be 1 equals a plus b, and 0 equals.
-3a minus 2b.
All right. So we could use substitution or elimination. What do you guys want to do? Substitution, I say a is equal to something and plug it in for the a. Where elimination means I multiply to try and add them together to cancel it out. What do you want to do? Second one.
Yeah.
So what am I going to multiply by? Say 2. I'm going to multiply this one right here by 2. And this is going to end up, so when I do this distribution, it's going to be 2 equals 2a plus 2b. Now, by doing that, what's going to happen?
Combining with the other one, it would be 2 equals.
What's going to happen to my b's?
It's just gonna disappear.
The b's go to 0,
Yep.
and that's what I needed. That's why I chose 2. What else would I have done to actually cancel out the a?
3.
I would have used 3 instead, right?
Yes.
Okay, just making sure. Listen,
Yeah.
I'm trying to teach it as if you guys never saw it before. Okay, so from here it's going to be, okay, I combine, so it's going to be 2 equals a, right? Or negative a, right? So a equals what?
-2.
Negative 2. So now that I know that a is equal to negative 2, what am I going to do for b?
We're gonna plug in a. And then we're gonna
1 equals negative 2 plus b.
Oh, okay.
So 3 equals b. Okay, so that's going to help me out now. So for my integral, it's now going to become my a, which is negative 2 over,
X minus 2.
what was it?
2. X minus 2.
X minus 2. And plus b, which is 3 over
X minus 3.
x minus 3, and that's going to be dx. Why do I like it like that now? The integration.
Integration of each separately.
Yes, each separately. And for each one, it's now going to turn in, because my degree is 1, it's now going to turn in just ln, right?
And another thing is the top is also the same as the minus thing. Is that just a coincidence?
That one's coincidence. Okay, so now as I do this, it's going to give me, so do my integration, it's going to be negative 2 ln,
X minus 2.
oh crap, ln absolute value x minus 2, right? And it's going to become plus ln of, oh wait, 3 ln of x minus 3 plus c. Huh? What? Alright, so because of those numbers out front, we could rewrite this using ln rules. If I have ln's and there's a plus sign between them, what does that mean? It's a multiplication, right? Okay, it's a multiplication, but if there's also a number in front of the ln, where that could be your what? That's your exponent. So I'm going to rewrite this. I'm going to rewrite it first intentionally incorrectly because it still has to be fixed. So I'm just going to move to all the exponents first. So it's going to be ln of, okay, this is going to be x minus 2, right? To negative 2 plus ln of x minus 3 to the third, right? Plus c. But now, I still have that plus sign, right? I still have that plus sign, so it's going to be a multiplication. But then I have a negative exponent over here, right? What's that negative exponent going to do? It's going to make it move under, isn't it?
Yeah.
So if I change this into a multiplication, it's now going to turn into a division, isn't it?
Yeah.
Because of that negative exponent. So it's going to be that I have ln of x minus 3 to the third over x minus 2 to the second plus c.
Yeah, and without rewriting it as a negative exponent, you can notice that you could have written it as 3 ln x minus 3 minus 2 ln x minus 2, and then right from there, because it's subtraction, then you would go straight to the division.
Yes, he rewrote it the other way. Because wouldn't it happen the other way anyway if I would have just said, hey, I put x minus 2 and x minus 3, right? But what if I said, hey, it's x minus 3 and x minus 2? Wouldn't that have happened anyway over here?
Yeah.
That still would have happened. I would still get the same answer, but this side would have been over here, right? And then it would have changed anyway. So there should have been a minus sign anyway. Either way, it comes out to be the same answer. All right. Okay. So for this right here, deriving formulas using rational functions. Derive these formulas. Okay. So if we're gonna do this, we don't actually need any numbers for this, do we? Say no.
Yes.
No, we don't. We don't need any numbers because we could actually just do this every time. Because aren't those differences of squares? When I factor those are differences of squares, right? So I'm going to do my first one. So x squared minus a squared. Insert page after. So it's going to be integration dx. So that's 1 over x squared minus a squared, like that.
Yeah.
And then dx. Okay, so that's a difference of squares. So I know that's going to come out to be, it's 1 over x plus a and x minus a, right? So that should be equal to a over x plus a plus b over x minus a. Yes?
Yeah.
We got about a minute. All right, so I'm gonna leave off here. I'm gonna pick it up tomorrow and trying to finish off these notes tomorrow. So don't forget, like, share, and subscribe. Today there's advisory. You guys come in here if you guys want some more help working on this. All right. Yes.